Welcome, viewers, to Bodhi Unified Flow. I'm Dr. Mari Muthu, your host, and here we simplify complexity and amplify performance. Today, we've got an absolutely critical explanator lined up for you. We're diving deep into the very best practices for the design phase, specifically focusing on planning and pre-construction. If you want to stop reacting to budget blowouts and start proactively engineering value, you are in the exact right place.
To make that shift from reactive guessing to strategic management, we're going to break this down into 4 core pillars. We'll start with elemental cost planning, move into formal value engineering, flip the script with target value design, and finally lock it all down with rigorous technical coordination. By the end of this session, the goal is simple. You're going to walk away equipped with the precise tools to safeguard your project's financial viability and literally eliminate waste before a single shovel even hits the dirt. We're talking mastering the RICS NRM1 framework, running the Save International methodology, deploying lean practices, and securing completely clash-free docs. Let's get right into it. Starting off with our first pillar, we really need to rethink how we handle money early on. This practice represents a massive paradigm shift for pre-construction. Historically, the industry has relied heavily on bottom-up estimating. Basically, you wait around for a detailed design, you price out all the materials, and then, surprise, it's over budget, forcing everyone into expensive, frustrating rework. Instead, we need to shift to top-down elemental cost planning. Think of an element as a major chunk of the building that does a specific job, like the substructure or the roof, regardless of what it's actually made of. We take an authorized budget right at day one and push it downwards into these functional buckets. It essentially guarantees your client is getting actual value for their money right out of the gate.
And this is a brilliant way to visualize it. Your financial advice has to mature at the exact same speed as the architectural design. Using the RICS NRM1 framework alongside the RIBA plan of work, it's a lockstep process. At stages 0 and 1, we set an initial order of cost estimate using high-level benchmarks like floor area. That's our anchor. Then, as the design evolves through stages 2 and 3, concept and spatial coordination, we sharpen those numbers into formal cost plans, locking budgets into specific group elements. By stage 4, technical design, we have a highly predictable pre-tender estimate, no surprises.
Now, the secret sauce here is that this plan is running. It's alive. It's not some dusty PDF sitting in an inbox. It evolves with every single design decision. We do this by constantly tweaking our element unit quantities, or EUQs, and our element unit rates, the URs. So early on, your interior partitions might just be budgeted as a flat percentage of floor area. But in a running cost plan, as soon as you know more, you swap that out for the actual linear meterage, multiplied by an analytical rate that factors in things like acoustic specs. Doing this at every single stage gate is how you stop tiny errors from snowballing before tender. All right, moving to our second pillar, let's clear the air on value engineering, because it gets a bad rap.
So often, people hear VE and think of someone just hacking away at the scope or cheapening the finishes to hit a number. That's not value engineering, that's just cost-cutting. True VE is highly systematic. To do it right and avoid crippling redesign fees, you have to run formal workshops at 2 specific times. First, right at the end of schematic design. Things are still fluid here, so you can actually swap out a whole structural system without ruining the schedule. Second, during design development, right when you're about 30 to 45% done. That's when you get granular, optimizing materials and crunching lifecycle costs.
I absolutely love this equation because it tells us exactly how to win. Value equals function performance divided by resources, meaning cost and time. It's just brilliant in its simplicity. You want to increase value? You have 2 choices. You either crank up the performance of the building without spending a penny more, or you maintain that baseline performance while actively squeezing down the cost and time.
But how do we actually execute that math in the real world? We use the Save International 6-phase job plan. It kicks off with the information phase, but the real magic happens in step 2, function analysis. You get a multidisciplinary team in a room and you strip everything down to a simple verb-noun pair. For instance, distribute power or support roof. You map costs to those specific functions to find exactly where you're overpaying for a secondary feature. Then, it's on to the creative phase for zero-judgment brainstorming, evaluating the best ideas, developing them with hard lifecycle cost math, and finally, presenting the optimized plan to the owner. It is a game changer. Okay, let's look at our third pillar, which completely flips traditional methodologies on their head. If you've been in this industry a while, you know the cycle. Design, estimate,
panic, rework. Target value design, which we actually borrowed from lean manufacturing, breaks that cycle. The cardinal rule of TVD is absolute. The target cost must never be exceeded. Period. You are designing to the cost. The budget isn't a surprise outcome, it's a primary constraint, just like gravity or building codes. So if terrible soil conditions suddenly spike your foundation costs, you don't go begging the client for more cash. The team works together to find offsetting savings somewhere else, maybe in the envelope or the MEP systems, to hold that total number flat. Pulling this off requires some serious lean discipline. First, continuous estimating. We're talking rapid-fire cost models every 2 to 3 weeks, so designers know instantly if they're drifting. Next is the big room. This is about physically or virtually co-locating the owner, architects, engineers, and key subs to utterly destroy communication silos. We also use set-based design, which means keeping multiple design options alive in parallel and letting the data decide rather than rushing to a single flawed solution. And finally, choosing by advantages. It's a structured way to make decisions based on actual, tangible benefits, rather than just arguing over subjective pros and cons.
And let me tell you, the data backs this up in a big way. Projects using TVD routinely finish 15 to 20% below market price. The ultimate proof is the spent budget ratio, final cost divided by original budget. If that ratio is less than 1.0, you just delivered a better building for less money. That is a massive win for everyone involved.
Moving on to our fourth and final pillar, let's talk about bulletproofing the deliverables. Before you even think about issuing a set of documents for tender, you need a ruthless quality assurance protocol. Let's be real. Mismatches between drawings and specs are the absolute biggest driver of RFIs and nasty disputes. You need a checklist covering disciplinary alignment. Does the ductwork smash into a structural beam? Do the electrical panels actually have their legally mandated clearances? You've got to check drawing versus specification alignment. If the drawing says acoustic glazing, the spec better define the exact sound transmission class rating. Everything must cross-reference perfectly. And lastly, bring the builders in for a constructability review to flag those long lead items, like custom switchgear, so they don't blow up your schedule later.
Now, the beautiful thing is, we don't have to do all this manually anymore with a red pen and a prayer. Modern AI and BIM tools are completely revolutionizing this space. Programs like Navisworks digitally hunt down 3D hard clashes before a single piece of steel is fabricated. We've got AI platforms like Stroll AI and InspectMind that can ingest hundreds of 2D drawing pages in minutes and flag omissions with over 90% accuracy. Insane, right? Tools like Toggle.ai automate takeoffs to power our continuous estimating. Embracing these digital workflows is how we crush field clashes and eliminate rework for good.
Okay, let's take a breath and tie all of these powerful concepts together.
Think about what we've covered today. We transitioned from waiting and reacting to proactively driving design with a running, top-down elemental cost plan. We learned how to maximize pure mathematical value through formal, structured VE workshops at the schematic and development stages. We totally shifted our mindset with Lean TVD, treating the client's budget as an unmovable design constraint. And we locked it all in by using cutting-edge AI and BIM tools to secure flawlessly coordinated, biddable documentation.
And just to ensure you know where this is all coming from, everything we unpacked today is rooted in the gold standards of the industry. We relied heavily on RICS NRM1, the SAVE International Value Methodology, the Lean Construction Institute's work on target value delivery, and the Construction Industry Institute. I highly, highly encourage you to dig into these frameworks to take your pre-construction game to the absolute next level.
I'll leave you with this final thought. As the entire construction industry races toward AI and data-driven delivery, mastering these protocols is no longer just nice to have. It is the defining characteristic of a leader. How are you going to apply these tools to strip away waste and deliver undeniable value on your next project? Thank you so much for spending your time with me today. Once again, I'm Dr. Marimuthu for Bodhi Unified Flow. Until next time, keep simplifying complexity and keep amplifying your performance.